Okay, so now we're dealing with the double rational inequality. So that means that there are going to be two fractions with a variable. So if I look at this problem, what we want to do is head back to chapter 0. That's when we did an expression and combining two fractions together, or two rational expressions together. So we're going to change this to an equal sign so that we could go back to what we want there. And then we are going to combine just one side. We want to combine them. We always want it to equal to 0. We don't want one on one side and one on the other side. We want to combine them. So this is where chapter 0 is taking place. So if you didn't know that, you have to go back and review this. But here we're going to review it really quickly. In order to add two fractions, we have to have a common denominator. It is not different when we're doing a rational expression. So what we want to do is that this one here is missing an x minus 1. And here we do not want to get rid of the denominator. If we wanted to get rid of the denominator, that's when you get the LCD, the least common denominator. Here we don't want to do that. Here we just want to combine them and not get rid of the denominator because we're going to need it to get the extraneous solutions. So here we want to make sure that we keep the denominator, and this one here is missing an x minus 1, so we're going to multiply an x minus 1, and here we're going to multiply by an x minus 5 because that's what's missing there. And so you're going to get one fraction, which is going to be 2 times x minus 1 minus 1 times x minus 5 with a common denominator of x minus 5 and x minus 1, and this is still going to equal to 0. Okay, so now we want to distribute the numerator. So we're going to get 2x minus 2. Don't forget to distribute. Some of you guys do forget to distribute to the last term. Minus, this is a negative 1 that gets distributed as well. And so it's going to be a negative x. And then, or you could put a negative 1x. And then it's going to be positive 5, and that's all over x minus 5, x minus 1 equals to 0, and then we're going to get x plus 3 in the numerator, and so we get x minus 5, x minus 1 equals to 0. So that was all from chapter 0. So now we're going to this chapter. Now we have that equal to 0 there. So we want to find the x-intercepts. So in order to find the x-intercepts, we set the numerator equal to 0, just like we did in the single one. And then we have x equals to negative 3. Now the denominator, this is when we set the numerator equal to 0. And then the denominator is going to give you the extraneous solutions, and that's when we do the denominator equal to 0. For further explanations on that, you need to watch the video on the single rational inequalities, and that explains why the numerator is equal to 0 and why the denominator equal to 0 gives you the extraneous solutions. So you set the denominator equal to 0. So we have this equal to 0. So we have x equals to 5, x equals to 1. So when we're graphing this, this is what we want. So we have this great graph, and I know that these are all x values, so they're all important. So I'm going to have a negative 3 here. I am going to have a 5 here and a 1 here. Now the extraneous solutions will never have a value, so we put an open circle there for the extraneous solutions and a dotted line because nothing is going to cross it. Nothing's going to be a value there. There is no x value on any one of them. Okay, so, but this one here is going to give us that there is an x-intercept at that value. So what it's going to look like is, I'm not expecting you to know what this looks like without a graphing calculator. So you could put the the very first one so you don't make a mistake. You want to put the first part into your calculator and then graph it. And then you have to look to see where it's actually crossing. If I put it in there, it's going to look something like this. And it's going to go through here. Now here it's equal to, so I know there's going to be a fill-in at the -3 because it's greater than or equal to, so the x-intercept is included in here. So we keep that in there, and so we do a solid dot there, and then it's going to have a little parabola going down this way, and then it's going to look something like this. It's a crazy graph, but we're using a calculator to do that for us, so that you could look at it. So now that you have it graphed, now we're going to answer the question. And the question is, if you remember, this part gives us the y value. So that part gives us the y value, because when I substituted an x value in there, what comes out of that side is going to be the y value. So that's what we have there. It's going to be a y value. Now this is asking greater than 0. So that means that we're looking for positive y values. So when I look at the graph, which ones are going to be positive y values? And in this case, the positive y values is everything above the x-axis. So these are positive y values, and these are positive y values. So to answer the question, it's going to be from -3 to 1. Now 1 is an extraneous solution, so we put parentheses because it's not going to be included. This x-intercept is saying positive y values including the x-intercept, because that's when y is equal to 0. It's greater than or equal to 0. When y is equal to 0, it's always the x-intercept. And since we're including it, we put a bracket there. And then union, because there's more, 5 is an extraneous solution, so we're not including it. So 5, and it's going to go to infinity. Now, I know that it's not going to cross it anymore because the only x-intercept we found here was this -3. So therefore, it can never cross all the way over here because the only x-intercept is -3. The other ones are extraneous solutions. So I know that it has to keep going and it's never going to cross the x-axis. Okay? All right. I think that would be about it. Repeat it, rinse and repeat.